Okay, so now we're going to be discussing about voltage division law. Now, just to give you an idea, the voltage division law allows tells us that we can divide a voltage or we can divide voltages into different elements as long as they are connected in purely in series with each other. So what does that mean? So for recall that recall a series connection like so. Let me draw it a little better. So the idea is these two resistors are considered to be in series with each other. How do we know? Well, we can always find a node that they share with each other that has no branching. Therefore, we're able to say that these are considered to be connected back to back and in series, or connected back to back, therefore in series. Now, what ends up happening is, let's say I wanted to know the voltage drop across here. Well, according to KVL, we just have that the voltage drop is equal to something like so. So we can find the current first. The current is just equal to the voltage divided by the sum of the resistors. So now if we were to ask, what is the voltage output? Well, it's just going to be that same current times R2. Now, if we expand this out, this is V divided by R1 plus R2 times R2. From here, this is where we get the term voltage division law. Like so. Notice that this voltage output is a ratio of the source voltage, or what we just call in this case V. So at any point, voltage division law just states that for a purely connected series, given a voltage source, we're able to find the voltage drop across an element, across a resistive element, as a ratio of some as a ratio of the source voltage. Now, just to keep it general, if you had an n number of series connections, the voltage drop would just be equal to that resistor element that we are interested in, divided by the sum of all resistors times the voltage source. And that's just the idea of voltage division law. There is one more interesting observation that I want to point to you about, and it's to do with this. Notice that R1 plus R2, since assuming must always be greater than R2, must always be greater than or equal to R2. If we divide, if we take away these, R1 therefore must be greater than 0. This important observation means that the voltage output is always less than or equal to the voltage input or the voltage source. Why is this the case? Well, we can't have negative resistors, therefore this statement would be valid. And because the bottom is always greater than the top, we're always going to get some kind of fraction, which leads to that the output voltage is always going to be less than or equal to the source voltage. Now, the situation where it is equal is if R2 is considerably larger than R1, such that we can neglect R1. Therefore, you will get that the output voltage is roughly equal to the source voltage. Experimentally, this gives us an understanding of voltage division law as basically a way to distribute voltages, and so that when we have two resistors connected together and one of them is variable, we can use that as a control voltage. And that's just the idea of voltage division law. When you have two or more resistors connected in series, we know that the current is constant, which leads to this generalized form, which leads to these two formulas, one being this specific case and the other being generalized. And this one's more of an experimental observation where in theory we know that the output voltage should be less than or equal to the input voltage. And this should make sense because we can't create more energy, and we certainly can't destroy energy. Therefore, the energy has to be redistributed. And that's just simply what this is. So, next, we're going to be then talking about current division. So,